Hello everyone, welcome to this session on data science process tips. In the previous presentation, we learned about the overall data science process. In this presentation, we will focus on the first two important stages, setting the research goal and retrieving data. These stages are very important because every successful data science project begins with a clearly defined objective and the right data. Setting the research goal. The first step in the data science process is setting the research goal. Before collecting any data or building any model, we need to clearly understand the problem we are trying to solve. A data science project should always start with a well defined objective because the goal determines what data we need, how we analyze it, and what outcome we expect. Without a clear goal, even a large amount of data may not produce useful results. So, data science is mostly applied in the context of an organization. So, this slide explains important elements involved in defining a research goal. First, we need a clear research goal. We should know exactly what problem we are trying to solve. Next comes the project mission and context. This helps us understand why project is important and how it support organizational objective. We also need to decide how the analysis will be performed and identify the resources required such as data, software tool, hardware and human expertise. Another important factor is determining whether the project is achievable. Sometimes a small proof of concept is created to verify feasibility. Finally, we define the expected deliverable, measures of success, and a timeline for completion. For example, if a college wants to identify students who are likely to fail examinations, the goal, success criteria, and expected outcome should all be clearly specified before stating the project. Next, retrieving data. Once the researcher goal has been defined, the next step is retrieving data. Data can be stored in many different forms such as text file, spreadsheet, database, cloud storage system, or enterprise repository. The objective of this stage is to gather all the data required to solve the problem. In most organizations, data collection begins with the internal data sources because they are readily available and often highly relevant to the project. So, data can be stored in many forms, ranging from simple text files to tables in a database. The objective now is acquiring all the data you need. The common sources include database, data mart, data warehouse, data lake. Each repository serves a different purpose and stores data in a different manner. As data science, it is important to understand these storage systems because they influence how data is collected and analyzed. Next, we can understand each storage system briefly. A database, it stores day-to-day operational data. For example, a college database may contain student records, attendance information, and examination marks. A data mart is a smaller repository designed for a specific department. For instance, the examination department may maintain only examination related information. A data warehouse is a centralized repository that integrates historical data from multiple departments. For example, admissions, academics, placements, and finance data may all be combined into a university data warehouse. A data lake stores massive amount of raw data in different format. It can store text, images, videos, PDFs, social media data, and log file without requiring a predefined structure. This progression shows how organizations manage increasing amounts of data. Now this slide shows the concept of data lake. A data lake is a centralized storage repository that can store both structured and unstructured data. Unlike traditional databases, data does not need to be transformed before storage. Instead, it is stored in its original format. According to Gartner, it is a collection of storage instances of various data assets additional to the originating data sources. These sources may include database, website, IoT devices, sensors, documents, images, videos, and social media platforms. The major advantage of data lake is flexibility. Since data is stored in its raw form, it can later be used for analytics, machine learning, and advanced data science applications. So data warehouse. Data warehouse is about collection of data from varied sources for meaningful business insights. and electronic storage of massive amount of information. It is a blend of technologies that enable the strategic use of data. Unlike a data lake, data is cleaned, transformed, and organized before storage. The primary purpose of data warehouse is to support decision making through historical analysis and trend identification. Managers often use data warehouse to generate reports and strategic insights. Now we can understand the terms data warehouse and data mart by using this schematic figure. A data mart can be viewed as a smaller portion of data warehouse. Instead of serving the entire organization, it focuses on a specific department or business function. For example, examination department data mart, finance department data mart, placement department data mart. If you look at the diagram, notice that the data is more focused and department specific. This allows faster access and simpler analysis for particular user groups. Next, we can show the comparison table based on the following aspects for data warehouse versus data mart. So coming back to the definition, data warehouse means large repository of data collected from different sources. Data mart is subtype of a data warehouse. Then it is in data warehouse, it is mainly focused on, it covers all departments in an organization. But in data mart, it focuses on a specific group or department. Coming to the design complexity, in data warehouse, design process is complicated. Compared to data warehouse in data mart, design process is easy. Then coming to data handling time, data warehouse it takes a long time for data handling, but data mart it takes a short time for data handling. Coming to size, data warehouse is large size, that is 100 GB to 1 TB or more, but in data mart it is small size, that is less than 100 GB. Coming to implementation time, data warehouse it takes 1 month to 1 year, but data mart it takes a few months. Next, we are going to understand the differences between the data warehouse and data lake by using this schematic. So here we are going to understand the key differences lies in the type of data stored in data warehouse and a data lake. A data warehouse mainly stores structured and processed data. A data lake stores structured, semi-structured and unstructured data in its original format. Data warehouses are optimized for reporting and business intelligence. Data lakes are optimized for big data analytic, machine learning and advanced data science application. In simple terms, a data warehouse stores processed data for reporting. A data lake stores raw data for future analysis and exploration. Again, we are going to see the differences between the data lake and data warehouse based on the following parameter. So coming to data structure, data lake. So here data is raw and all types, that is structured, semi-structured or unstructured. It is captured in its original form. Coming to data warehouse, data is processed and only structured information is captured and organized in schemas. So coming to the parameters users, data lake which is ideal for users who carry out deep analysis such as data scientists and need advanced analytical tool. So in data warehouse users which is ideal for operational users such as business professionals and moguls since the data is structured and easy to use. Coming to storage cost, in data lake, storing data is relatively inexpensive. In data warehouse, storing data is time consuming and costly. Coming to accessibility, in data lake, updates can be made quickly, thus making it highly accessible. But in data warehouse, it is costly to make changes, thereby quite complicated. Coming to position of schema, in data lake, schema is defined after data is stored, thus making it highly agile. In data warehouse, schema is defined before data is stored, thus offering performance and security. Coming to data processing, data lake it uses ELT, that is extract load transform process. In data warehouse, it also uses ETL, extract transform load process. Next, we are going to discuss the features of data lake. As organizations generate increasing amount of unstructured data, data lakes are become more important. Some experts even predict the data lake may eventually replace traditional data warehouse for certain application. However, data warehouse remains highly effective for structured business reporting. Therefore, many organizations use both data warehouses and data lake together depending on their requirements. Next, we are going to discuss about various data providers. Data providers are the source from which organizations obtain data. They may include many database, that is internal database, government database, open data repository, social media platform, sensors and IoT devices, cloud services, third party vendor. So many open data sites are there. So next session we can discuss the foundation for the next stage of the data science process, which is data preparation. Thank you for your attention.